Hello and welcome to COOLTEK, my energy efficient home. It was built in the year 2004 when my late husband and I moved to Malaysia. Our concept in designing and building COOLTEK, a single-story bungalow in a lush jungle location in Tiara Malacca Golf and Country Club, was to provide us with a comfortable environment where we could live and work without the penalty of excessive air-conditioned energy costs. So, with all of our experiences of living in England trying to conserve energy, where we learnt to reduce loss of heat and use incidental heat and solar gain wherever possible, we began our quest to use the natural resources and latest technology to produce a home with an affordable, comfortable atmosphere. Here in Malaysia, we needed to keep the cold in rather than out and treat the sun as an enemy rather than a friend. Living in the West for the major part of our lives, we were aware of the need to conserve energy and limit the use of fossil fuels to help ensure the continuing survival of all animals and plants, and even the planet itself. To continue this aim, we were in Malaysia, having built what may be called our 1 million ringgit experiment in conservation. I am happy to share our knowledge and experiences with those of you ready to listen. COOLTEK is a single-story detached bungalow with a built-up area of 2,800 square feet, including 2 bedrooms, living room, computer room, kitchen and attached garage for 2 cars, along with a workshop and store. The actual living area of 2,200 square feet is air-conditioned 24 hours per day to provide a comfortable environment with the temperature kept at around 24 degrees centigrade and a relative humidity of 55%. The daily air conditioning consumption is just 10 kilowatt hours per day. Insulation, shading, high-performance window glazing and air tightness, together with constantly cooled air underground through ventilation, are among the energy-efficient features employed in COOLTEK. Looking at electricity consumption in the home, and in particular that used for air conditioning our homes, it is evident that energy efficiency in the home is important. Here are a few facts to contemplate. The electricity used by the residential sector in the European Union in 2004 approached 30% of the total energy consumed. With the ever-increasing use of air conditioning in homes in Malaysia, similar energy consumption levels dictates the need for energy-efficient construction and appliances. Taking Japan as an example, in 2006, air conditioning accounted for 27% of the total domestic electricity consumed, again emphasizing the need for green and sustainable homes. Sensible choice of appliances and lighting will also add to the overall energy savings within the home. COOLTEK has 5 design features, the first of which is protection from the sun. COOLTEK is located in the most wooded part of the Tiara Malacca Golf and Country Club in Ica Row, Malacca, and has large jungle trees on 3 sides, taking advantage of their natural shading. From 4 p.m. in the afternoon, the roof covering the sleeping area of the building is shaded from direct sunshine. The roof trusses are made from high tensile steel, covered with zinc aluminium coated steel cladding, finished with a bonded painted system. The white colour of the steel roof reflects much of the sun's heat during the daytime, and the steel structure allows any heat accumulated during the day to quickly dissipate as soon as the sun disappears below the horizon. To reduce the heat from the sun increasing the temperature inside the building, wide roof overhangs shade the single-story building and, importantly, the windows, which are set at the inner side of thick heat and sound-resisting walls. White walls and doors also reflect much of the solar heat away from the building. The second and important design feature is orientation to the sun. Making best use of the building site, the main part of the building is positioned so that the air-conditioned living area, shown in blue in this figure, has windows facing only south and north, thereby preventing the hot rays from the sun entering the home and increasing the temperature. A simple no-cost design feature which could be easily incorporated into most bungalow and even low-cost developments. The third design feature of COOLTEK is ventilation, which is different to most houses, as it is underground. Underground cooling of fresh air is used successfully in other climates, especially where there are high diurnal temperature swings, but it is not common in the hot and humid tropical Malaysian climate with a daily temperature range of just 10 degrees centigrade. Modern Malaysian architecture has high ceilings in an attempt to allow the heat to rise. Therefore, to provide ventilation for a sealed house, COOLTEK was designed and built to have a below-ground ventilation system to bring cooled, filtered fresh air into the house at one end and a large thermal chimney to expel heat at the other end of the building. The ventilation system collects fresh air from underneath a large leafy tree in the nearby jungle, passes it along large PVC pipes into two large concrete chambers, and circulates it around upright cooling ceramic pipes before entering the house from beneath the ground. The warmer stale air is ejected up a thermal chimney via large ceiling vents in the air-conditioned area, wet kitchen and roof space. The design uses thermally simulated airflows with the hot air expelled from the chimney, thereby drawing cooled air through the underground chambers. Air enters at a temperature which is the average between day and night, around 27 degrees centigrade. The fridge freezer was set into the foot of the chimney to add to the hot air convection and also to make its operation more efficient. The chimney was built with dark red engineering bricks to increase the solar thermal capture and thereby generate more thermal lift. These next pictures show how the ventilation system was installed during the course of the construction of COOLTEK, with the aim of bringing cooled fresh air into the house 24/7. This first picture shows the pipe coming through the concrete foundations into what is now my bedroom. This second picture shows the other end of this pipe at the lower level, ready to be connected to the chambers. Here we see the two concrete chambers in position. The pipes from the previous picture are connected but out of view. The two pipes coming from the concrete chambers are the main feeds to the system and are open to the atmosphere. It should be noted that the concrete chambers stand on a thick base of concrete, and the tree, which is sheltering the system, is in the bottom left-hand corner of this picture. Looking down into one of the chambers, you can see the ceramic pipes standing on their end. They are arranged like this so the air has a difficult passage through the chambers, so we get maximum cooling to the air. Finally, thick concrete lids were added, and now The whole system is covered with soil and plants are growing happily above it. And going to the other end of the system, we see the chimney being built above the roof and finally finished with a covering so that the rain cannot get in, but the air definitely gets out. The prime materials that make COOLTEK so different to standard Malaysian homes are those that insulate the interior of the building from the cruel heat outside. All the walls, windows, floor and ceiling are insulated to resist heat entering and to contain the cool air-conditioned atmosphere inside. The 250mm thick walls in the air-conditioned area are built with lightweight aerated blocks and are painted white on the outside. Building with aerated blocks is quick and easy, and they have excellent insulating properties that resist most of the heat and sound from outside transferring into the rooms, as well as keeping the air-conditioned coolness from escaping. They are laid as load-bearing walls without any steel-reinforced concrete skeleton and use special thin adhesive. Both of these features help to minimize heat transfer into the building. COOLTEK uses large picture windows that do not open, and all external doors are provided with double rubber seals. The windows and external doors are double glass, bought from England. The inside layer of glass has a special clear, low emissive coating, and the space between the two layers of glass is filled with argon gas, so that the heat cannot pass easily through to the inside of the house. The door sills and non-opening windows keep out heat, but also dust, noise and insects. A very dense 50mm rock wool blanket above the ceiling helps to stop the heat above radiating down into the rooms, and also resists any transfer of the air conditioning coolness to the hotter roof space. A layer of high-quality tough aluminium coated foil is laid immediately below the roof cladding, reducing the radiation of the heat down into the roof space. As hot air rises, cold air sinks. So more importantly, a 50mm layer of polyurethane was laid below the floor finishing to resist the air-conditioned cool air sinking into the concrete foundation slab below and heading down towards the center of the earth. The final design aspect is the use of technology to make the effectiveness of COOLTEK as good as possible. All domestic appliances and equipment used in the house are as energy efficient as possible at the time of purchase. The two major features now described are what make COOLTEK probably the most energy efficient home in Malaysia. When designing an ecological home, it is almost necessary to have water heated directly by the sun's energy. The choice is between electricity from a local power station, using up valuable non-renewable resources and producing large amounts of damaging carbon dioxide, or connecting to nature's power supply some 150 million kilometers away, and which gives out endless free energy. Our award-winning solar water heater system from Microsolar, which claims to have the highest efficiency and the maximum temperatures in the world, is by some incredible coincidence designed and manufactured in Malaysia. Constant hot water up to a remarkable 86 degrees centigrade is available even on a dull day or early in the morning, and supplies all the hot water needed for a long bath, showers, washing machine and sink. In June 2007, we were fortunate to be awarded help under the Syria 1000 building integrated photovoltaic project being implemented by Pusat Tenaga Malaysia to install a 4.8 kilowatt solar system. Installation of the system was completed in October 2007, when it produced around 65% of the electricity we needed. It consisted of 40 panels placed on our roof, 20 of which faced south and the other 20 facing north. Following the launch of the feed-in tariff in late 2011, COOLTEK system was approved and commissioned under this scheme in February 2012. Since then, we have received 1 ringgit 46 cents for every kilowatt hour the system produces. With the use of more efficient air conditioning units and other electrical appliances replacing the older ones, the system now produces over 100% of the electricity required to run COOLTEK. This graph shows the total amount of electricity generated by the system for the years 2008 to 2020. It should be noted that for the years 2018 and 2019, the panels needed cleaning, which affected the amount of electricity they generated. Only electricity generated for the months of January to September are included for the year 2020, but it is anticipated that for the whole year, over 5,000 kilowatt hours will be produced. And finally, here is a summary of all the features that make COOLTEK such an energy-efficient home. Hopefully you will have found it interesting and useful, and if you wish to contact me, my email is in the credits.